Our topic here in 3.8 is the derivatives of inverse functions. So we know a little bit about inverse functions. You made inverse functions in your function booklet. Functions are inverses if they undo each other. So I have here the graph of f of x, which is x squared. Looks like a parabola. I could take the derivative. I'm really good at taking derivatives of polynomial functions now. The derivative is 2x. I'm going to focus in on one point on this function. I'm going to look at where x is 2. When x is 2, y is 4. So I'll put a dot on the graph. I could now find the slope of the tangent line to that point I just graphed. I'd use my derivative, I'll plug in 2 for x, and I find out that the slope happens to be 4. I'll draw in the tangent line. Now here was just a coincidence that the slope and the y value happen to be the same. I'm going to show you what it looks like if I put the inverse of y equals x squared on the same picture. So the inverse, remember how to find the inverse, switch the x and the y, and then resolve for y. The inverse function of x squared is the square root of x. So here's a graph, square root of x. And notice, here's something you already knew about inverse functions. If there's a point 2, 4 on f, then the point 4, 2 must be on f inverse. So if a, b is a point on the function f, then its inverse, f inverse, must contain b, a. There's a place for you to fill that in your notes. Well, that's old news, stuff we already knew about inverse functions. I can find the derivative here. If f inverse is square root of x, I can find the derivative. I know how to take the square root of x squared. I know how to take the derivative of x squared. I get 1 over 2 times the square root of x. Here's something you might not have known, because we didn't talk about derivatives until this year, or slope. That point on f inverse that contains the ordered pair 2, 4, but just switched, so 4, 2, that's called the corresponding point on the inverse function. So 2, 4 on y equals x squared has a corresponding point of 4, 2 on square root of x. 3, 9 on y equals x squared has a corresponding point of 9, 3. So here's the corresponding point, 4, 2. And just notice, what if I compute the slope at this point? So I'm going to plug 4 in for x into the derivative, and I get 1/4. This is what's new, and this is what's important for your calculus success, and it's what's exciting. At corresponding points on inverse functions, slopes are reciprocals. All right, so in your book, on your notes paper, there's a place for you to write, if a function f contains the point a, b, and has a slope m at that point. So in this case, y equals x squared contains 2, 4, and has a slope of m equals 4 there. Its inverse function is called f inverse, like we have over here on the left side of the screen, f inverse of x. That's f with a little -1 exponent. That must contain the point b, a, and must have a slope of 1 over m at that point. So at corresponding points on inverse functions, slopes are reciprocals. I can show you the math to prove that this is true. This statement that's just popped up here. It could be helpful. Feel free to memorize it. I'm going to show you how I like to answer the kinds of questions that you're going to see on the AP test that use this principle. All right, so the derivative of the inverse function evaluated at the y value of the regular function, which is the x value of the inverse function, is the reciprocal 1 over the derivative of f of x evaluated at x equals a. So this is the common kind of problem that you could see on the AP test. If f is a differentiable function, and we have some information here, I know that f of 3 is 15, f of 6 is 3, f prime of 3 is -8, and f prime of 6 is -2. So we could use that formula that showed on the last slide. Really, this is how I solve a problem like this. It says the function g is differentiable, and g of x is f inverse x. So f and g undo each other. F and g are inverses. That means if a comma b is on f, then b comma a is on g. Your question here is, what is the value of g prime of 3? So this is what I do. I make a little table, one for f of x and one for g of x, or I could call this f inverse. I'm going to try to fill this out because on the two functions, there's going to be some ordered pair and a slope at that ordered pair, so the derivative at that ordered pair. So I know the x value I care about. Alright, this is what I do. I know that I want g prime of 3, so the x value I care about on the g function is 3. So I have to figure out what the corresponding ordered pair is on the f function. Well, if 3 is the x on g, then 3 must be the y on the f function, so I fill that in next. And now I can go up to the information from the problem and figure out which x goes with y equals 3. Up here I see f of 6 equals 3, so I know the x that goes with a y of 3 has to be 6. So if I know on the f function I have the ordered pair 6 comma 3, on the g function my ordered pair is 3 comma 6. Now I can fill in the slope. At 6 comma 3 on the f function, the slope must be -2. So on the g function at 3 comma 6, the slope must be the reciprocal, -1/2.